Hello and welcome everyone. My name is Ahmed Amir as a dean, and I hope you are all doing well. I'm from Group 1, and today we're going to be explaining on the raw echelon form and reduced raw echelon form. And we're also going to touch a little bit on the rank of a matrix. With me in this video will be Abdalla Abbas al-Hashimi and Abdalla Gamaledin Ali and Omer Yousif Ali. So without further ado, let's get started, and I hope you all get a clear understanding from this video. Uh, Before we proceed to the raw echelon form and the reduced raw echelon form, I want to revise with you all the concept of a matrix. A matrix is a rectangular array of numbers called element, arranged in rows and columns. A matrix with m rows and n columns is called a matrix of order mxn. Matrices have a lot of applications in our world. Uh, One of these applications is in the wireless communication field. They use a lot of matrices to optimize the system. Also, in the computer graphic field, they use matrices in the transformation of objects and transformation of stuff. So there are two types of the echelon form. First one is the raw echelon form, and the second one is the reduced raw echelon form. The matrix need to meet certain requirements to be in these forms. So there is like some conditions the matrix must meet to be called a raw echelon matrix or a reduced raw echelon matrix. As you will see in the following slides, like the conditions are basically the same, but there is like one or two additional conditions for the reduced raw echelon matrix. So let's start with the raw echelon matrix with my friend Omar.
Assalamu alaikum. Hello guys, I am Omer Yousif and we are going to talk about row echelon matrices, REM. The row echelon matrix is a matrix that has four properties. The first one of the properties is that it needs to contain at least one non-zero row. That means it must not be a zero matrix. The second property is that the leading one in any row must be 1. The leading one is the leftmost non-zero entry. And the third property is that the leading one in the lower row occurs further to right than the leading one in the upper row. The last property is that if the matrix have a full zeros row, it must be in the bottom of the matrix and must not be in the middle or in the first row of the matrix. And if there is more than one zero row, they have to be grouped together at the bottom of the matrix. Let's see some examples to fully understand these properties. As we see here, this is a general formula. The component of the diameter of this matrix need to be all ones if you need it to be a row echelon matrix. Let's see the examples. The first one here, as we see, it is not a row echelon matrix because of the third property, which says the leading one in the lower row must be to the right of the upper leading one. This matrix is the row echelon matrix because it satisfies all of the four properties. And this one is also REM because no property of the four properties was violated. In this one, we can easily say it is non-row echelon matrix because the leading one in the first row isn't 1. And this matrix is REM because it also satisfies all of the properties. This one here isn't row echelon matrix because it has a non-zero row in the middle of the matrix and it must be at the bottom. The last matrix here is REM because it satisfies all of the properties. Yes, it has a non-zero row, but as the fourth property says, it is at the bottom of the matrix.
Reduced row echelon matrices. For a matrix to be at reduced row echelon form, it needs to meet the four previous requirements and one more additional property, which is that each column that contains a leading one has to have zeros everywhere else in the same column. Knowing this, we can consider every reduced row echelon matrix to be a row echelon matrix. But not every row echelon matrix is a reduced row echelon matrix. We have two examples of reduced row echelon matrices. They both satisfy all 5 properties as they are not zero matrices. They follow the staircase rule. The first non-zero entry in each row is a 1. They don't have 0 rows in the middle of the matrix. And each column that contains a leading 1 has zeros everywhere else. Here and here and here. This column does not matter because it does not contain a leading 1. Rank of matrices. The rank of a matrix is the number of rows that is non-zero in each echelon matrix or reduced echelon matrix. The rank of a matrix is denoted as P of A. For example, in this first matrix, we have 3 non-zero rows, which makes the rank of the matrix 3. And the numbers after the leading one are hidden because they don't matter in this context. We only need 1 non-zero entry in each row to count the rank. Moving on to the next example. This is a 4x4 matrix. It has 3 non-zero rows. The last row is a 0 row, so it does not add to the rank, and the rank is 3. And in this example, we have a 3x2 matrix. Only 2 rows have non-zero entries, which makes the rank 2, and so on.
Everyone, I'm going to continue with the topic of matrices with some basic exercises to determine what type of matrix it is. So on the exercises, we have to determine if it's either a row echelon matrix, reduced row echelon matrix, or neither. So we're going to check an example for every one of those in these matrices. So for the A matrix, we're going to check the properties. We're going to check the properties, right? So the first property says it does not have to be a zero matrix. We are seeing here 1 1 1, so it's not a zero matrix. We're going to jump to the next property and check it. The next property says the leftmost non-zero entries in every row should be a 1. So the first non-zero term in every row on the matrix should be a 1. As we're seeing, it's a 1 here and a 1 here and a 1 here. The third property says the leading one on the lower row occurs farther than the right to the leading one on the upper row. So the property basically saying if we're having a 1 here, the next one on the matrix should be on the right down to the next first one. So it's a 1 here, the second one should be here. As we're seeing, it does not satisfy the property, so it's not a row echelon matrix or reduced echelon matrix, so it's neither. We're going to jump to the G matrix and check it to see also. Firstly, we're going to check the properties as we did on the first matrix. We're going to check the properties. We are seeing it's not a zero matrix, so it does satisfy the first property. The second property, the first non-zero term should be a 1, a 1, a 1, a 1. So it's not. It does satisfy the second property. And for the third property, the 1 should be in the staircase type. So we're having a 1. Okay, wait. We're having a 1 here. The next one is on the right down to the next one, so it does satisfy. Also, the third is on the right down to the 1, so it does satisfy the property. So the matrix is either row echelon matrix or reduced row echelon matrix. We're going to check that property of the row reduced echelon matrix and check if it's either this or this. So the property says each column that contains a leading 1 has 0 everywhere else. We're going to check the column that has a 1 on the matrix. Firstly, we're going to check this column because it have a 1. we're seeing that all the zeros beside the 1 is equal, it does not have a value, it's a 0 and 0, so it does satisfy the property for the first row, for the first column on the matrix. On the second column that have a 1, we're going to check again, and we're seeing here 2. 2 means there's not a 0 everywhere beside the 1 here, so it does not satisfy the property, so it will be a row echelon matrix, because it does not satisfy the property of the row reduced echelon matrix. So it's a row echelon matrix for the G matrix. So we're going to have another example. So for example, let's try the X matrices. We're going to check as we did on the G and the A matrix. Firstly, we're going to check if it's not a 0 matrix. As we're seeing, it's not a 0 matrix. So the first satisfy the... Also, the second and the third properties are satisfied in these equations, in this matrix. So it's either row echelon matrix or reduced echelon matrix. We're going to check the property of the row reduced echelon matrix, and we're seeing all the ones have 0 terms on the column, or every column that have a 1, the other terms would be 0 in the column. So it does satisfy, so it's a row reduced echelon matrix for the H property, and we'll do the same steps for each of these matrices to get the final answer, to get what type of matrix it is. And after we're doing this, we'll get this.